This video is going to explain to you a primary standard solution, which is where you're up to in this achievement standard. So if you're wondering what is a primary standard solution, it's simply a solution that can be made by dissolving a solute, which is a solid, into a solvent, which for example would be water. Because we have weighed out the solute and we know the volume of water that it goes and dissolves into, we would know the concentration of this solution accurately. And when you know the concentration accurately, this can be a standard solution. So this diagram explains or shows the steps involved in making the solution, which is what we will do in class. This diagram is on the bottom of page 8 in your workbook, the notes that you were given in class. So your first step is to weigh out the solid, so we'll be weighing out sodium carbonate. You then just add a small amount of water to that to mix it up a little bit and get it into solution. And using a funnel, we transfer it into this piece of glassware, which is called a volumetric flask. And the volumetric flasks we'll be using will be 250 ml volumetric flasks. Make sure you get all the solid transferred out of your container by using a water wash bottle and squirting through and just rinsing through all the solid out of that container. Once you've got it completely rinsed out, we then start adding water to the flask and again mixing to make sure that all the solids dissolved. And then the last step is to use an eyedropper and get that meniscus to sit right on that calibration line. So it does need to be very careful when you're adding those last few drops that you add enough but not too much, and that is to get the meniscus on the line. That's how you know you've added the correct amount. Once we've done that, we'll put the lid on, the stopper, and invert it a few times. Make sure that it's well mixed and you're ready to use it for the titration process. So the trick question is, how much do you weigh out? And you're going to find that there's a calculation shown in your DIO workbook on page 9. It asks us to prepare a 250 ml standard sodium carbonate solution. So that's the volume there, 250 mils. And the concentration needs to be about 0.100 moles per litre, so a 0.1 molar solution. There are two calculations you need to do. Your first calculation is first to convert those two values and find the amount of sodium carbonate. So the amount is how many moles, and that is got the symbol N. And to do that, we will take the concentration and multiply it by the volume. We can see that the concentration is supplied 0.1 mole per litre, and we multiply it by the volume. Now be careful, your volume needs to be converted to litres so that these units, moles per litre multiplied by litre, cancel out, and when you do that your answer will be in moles. So this instance, 0.1 times 0.250 litres, okay, so 250 mils is 0.250 litres, and so your answer at that point is 0.0250 moles. Now if you wish, you can convert that or write that in standard form. It's not compulsory to do so. Now your second calculation is to determine the mass of sodium carbonate. To do that, we need the amount, which we have just got in step 1 of the calculations, and we multiply it by the molar mass. Remember, to find molar mass, if it's not supplied to you, you need to use your periodic table and work out the mass of each of the elements and sum it together. So when we've got the amount, and the molar mass. We multiply those two values together and you'll get the mass of sodium carbonate. So in this instance, we're going to be weighing out 2.65 grams of sodium carbonate, which we would dissolve in 250 mils of water. You will need to know some detail about what makes a good primary standard. Not all solids are good primary standards. To be a good one, firstly, your solid needs to be soluble, okay, which means it needs to dissolve. It needs to be obtained in a pure form so that when you're weighing it out, it is pure, for example, sodium carbonate. Not all solids are pure, so that's a second requirement. The third requirement, you need to know its formula so you can do the calculations and know its molar mass. The solid that you need to be weighing out also must be able to be stored without deteriorating or reacting with substances in the air. A very common reactant in the air is carbon dioxide. So sodium hydroxide is not a good primary standard because it does absorb carbon dioxide from the air, which will affect the alkalinity of the sodium hydroxide. Carbon dioxide, when it dissolves in water, is acidic, so it would affect the sodium hydroxide alkalinity. A primary standard solution of oxalic acid is a good one that can be made, and we can use that in a titration with against the sodium hydroxide, and that would actually make the sodium hydroxide a standard solution. Again, don't worry about this third bullet point. I'll explain more about that in class. There is a difference between a primary standard solution, which is one where you dissolve the solid, and what we call a standardized solution, which is one where you've worked out its concentration using a titration. That's probably a little bit too much information for us to discuss in this video while in lockdown. So takeaway things that you should know about what makes a good primary standard are these 5 bullet points here. It's got to be soluble, be obtained in a pure form, have a known formula, store without deteriorating, and it mustn't react with substances in the air. Sodium carbonate does make for a good standard primary standard, so that's why you'll be using that when you make yours in class. It's got these qualities. It is a high molar mass, so that when you do weigh it out, you get very small error when you weigh it out. It's very stable, although it can absorb some water from air. It's easily removed, that water, because you just put it in the oven and it will dry it out and make it anhydrous again. Remember, anhydrous means that it's dry without water of crystallization. It reacts quickly. This is the sodium carbonate. It will react quickly with things like hydrochloric acid when we're doing the titration. So the color change at the end point is seen easily. Sodium carbonate is very readily available. We can get it easily. It's pure, it's cheap, and as I say, it's available. And the anhydrous sodium carbonate, that's the sodium carbonate that's been dried in the oven, is ideal to use, as then it won't lose any further water on standing, and it also doesn't absorb water or carbon dioxide from the air. On page 9 of your DIO workbook, you have got instructions on how to make your sodium carbonate solution, and we will be doing this in class hopefully this Thursday when lockdown's finished. So 2.65 grams of sodium carbonate is going to be weighed out, and then we will transfer it into this 200 ml volumetric flask, fill it with distilled water, and give it a good invert, which means turn upside down, and swirl to mix. And we'll be making sure that that water goes right onto the calibration line. There's a calibration line on the flask. When you get it in person, you'll see it. So what do you do for the rest of today? I would like you to carry out a few calculations which are here on page 9. What you're doing in these ones is calculating the mass of solute that you need to prepare the following solutions. So notice in question 1, they want you to prepare 100 mils of a 0.05 mole per litre solution. And in question 2, they want you to prepare a 500 ml volume of 0.01 moles per litre. I have got the answers available on DioConnect, and they're also in this video. You'll need to press pause to look at the answers. And then questions 3, 4 and 5 are slightly different. They're telling you the mass of solid you are dissolving, and from there they want you to calculate the concentration. They have told you the volume. So pause the video and you will be able to check the answers for these questions. If you have any problems whatsoever, come back and chat through the Microsoft Teams with me and I'll help you through those steps. So this is the answer to question 1. You can push pause and it will you'll be able to check your answer against this one. Whoops, notice I went too far. So notice that there's 2 steps. Your first step is to calculate your concentration times your volume, which gets the amount of the sodium carbonate. And then step 2, you need to multiply the amount by the molar mass. Here is question 2, the answer. So push pause. This is the answer to question 3. Notice this time you are not calculating the mass, you are calculating the concentration. So step 1 is to work out the amount by taking the mass over the molar mass. That gives you the amount of sodium carbonate. Step 2 is to divide the amount, so that answer in step 1, divide it by the volume. Notice the 250 mils has been converted to litres. There's question 4 answered. And there is question 5 there. I will see you in the next online lesson.